Just a reminder, we talked about earlier, concentric circles share the same center. So you can see the picture there on the right. And then the measure of an arc is in degrees, while the arc length is a fraction of the circle's circumference. We're finding the measures of angles formed by tangents and secants. We will use the measure of the arc in degrees, not the arc length. All right, so a tangent to a circle is a line in the plane of the circle that intersects the circle at exactly one point. So it is a line that meets the circle at exactly one point. The point where the circle meets the line is called the point of tangency. So here you can see we have, line BA is tangent to the circle at B. Or you could say ray BA is tangent to the circle, or you could just say segment BA is also tangent to the circle. So you can look at it as a line, a ray, a segment. Next we have some theorems, and our first one is our Tangent-Radius Theorem. And this says if a line is tangent to a circle, then the line is perpendicular to the radius at the point of tangency. So the radius that you draw from the center of the circle to the tangent line will always be perpendicular. So the radius that can be drawn from the center of the circle to the point of tangency on a line or a segment or a ray will always be perpendicular to that line. All right, so here our next theorem is if an angle is formed by two intersecting tangents, then the measure of the angle is 1/2 the difference of the measures of the intercepted arcs. So what we are going to do is I'm going to draw, so if we had a circle, here's our circle, and again, I apologize, my stylus does not draw very well. And then we had two circles that were tangent to the circle. So here's one point of tangency, and here's another. We'll call that A. We'll put another point B here, and we'll call that C. Okay. Now, the measure of the angle formed. So the measure of, we'll call this the vertex of the angle D. The measure of angle ADC is going to be equal to 1/2 the difference of the measures of the intercepted arc. So it's going to be equal to 1/2 times the measure of arc ABC. I know that didn't come out very well. Sorry. Let's make that better. Arc ABC minus arc, the measure of arc AC. So it's half the difference of the two measures. So let's say, for instance, if I know that the measure of arc AC is equal to, we'll say 120 degrees. If I want to find the measure of angle ADC, I need to know the measure of the other intercepted arc ABC, but the two arcs make up the entire circle. So if I did 360 minus 120, we would get, for our other intercepted arc, 240 degrees. So the measure of arc ABC is 240 degrees. So now to find the measure of my angle. The measure of angle ADC is going to be equal to 1/2 times 240 minus 120 degrees, and that will be 1/2 times 240 minus 120 would be 120. So we're going to have the measure of angle ADC is going to be equal to 60 degrees. And here's a little trick. Any angle that is formed on the outside of a circle, whether it be from two tangents or a secant and a tangent or two secants, will always be 1/2 the difference of the intercepted arcs. Next, we just have the converse of the tangent-radius theorem, and that just says that if a line in a plane of a circle is perpendicular to a radius at the endpoint, then we know that that line is tangent to the circle. On the next few slides, we're going to take a look at just different ways lines can be tangent to circles. Two circles can share a tangent line. Common tangents can be lines, segments, or rays that are tangent to more than one circle. And then in the next few slides, we're just going to take a look at different ways they can be tangent to two circles. All right, so here we have two circles. They overlap, and they have two external tangents. So you can see the green lines there. So the two lines touch both the top or the bottom parts of each circle. Now we have two circles with three common tangents. So you have the two external lines we saw before, and then because the two circles only meet at one point outside on their circumferences each, you have that black line going down. That could be an internal tangent. So it would meet the circles at exactly one point. Next, we have two circles that are not concentric. So they don't share a common center, but they do share a common point on the circumference of each circle. So we have a line that is tangent there. All right, and if you have two circles that are either concentric or one circle is inside the other and they may not have the same center, there can be no common tangents. There's no lines that can touch both circles at only one point. Right, and then here on this slide, we have two circles that they don't touch, so they don't have any common points. But if you have two circles, you can have four common tangents. So you can have the two green tangents on the outside, or within the inside, you could have, you can see the two lines meeting in an X. You can have other lines meeting the two circles to be tangent to those circles. Next, we're going to talk about the congruent tangent segments. So if you have two tangent segments to a circle and they share a common endpoint, so they form that outside angle, then those two segments are going to be congruent to each other. So they're congruent from the point of tangency on the circle to the point where they meet or intercept. So think of it as the 2 points on the circle and that angle that's formed to the vertex of the angle. Right, so here we're going to find the value of x. We know that line AC and AB are tangents to circle D, so they meet at point C and B to the circle, and they intersect at point A. And they want us to find the value of x. We just learned from our previous slide that the two segments, the congruent tangent segment theorem, that the two segments are congruent to each other. So that means that I know that x squared is equal to 10x minus 9. And they want us to find x. So now this is going to be a quadratic. So to solve it, we need to set it equal to 0. And we want to keep x squared positive. So I'm going to subtract 10x from both sides. And I have x squared minus 10x is equal to negative 9. And then we'll add 9 to both sides. So now we have x squared minus 10x plus 9 is equal to 0. And then if you recall, to solve this, we need to factor our equation. So x squared minus 10x plus 9. Remember, it would factor into two binomials. And we would have x and x. Because it's a minus and a plus, we're going to have two minus signs. So now I need to figure out what can multiply to give us 9 that can also add to give us a negative 10. Now for 9, I know we can do 3 and 3, but that doesn't add to give me 10. And then 1 and 9 would also work. So we're going to put our 1 and 9 there because they add to 10. And then to solve it, we just set our equations equal to 0. So we have x minus 1 equals 0 and x minus 9 equals 0. And then we'll just solve our linear equations. So x is going to equal 1, and then x will also equal 9 for our equation. So we have our two solutions there, 1 and 9. All right, next we're going to talk about secants. And secants are a line, or again, it could be a segment or array, that intersects a circle at exactly 2 points. So a secant, if I have a circle here, okay, a secant will meet at 2 points. And then if you have two secants that form an angle outside of your circle, the measure of this angle right here is again going to be equal to 1/2 the difference of the measures of the two intercepted arcs. Now this time, this angle measure is going to be equal to 1/2 the measure of this intercepted arc and the difference. So the difference between these two. So I would take the larger one, subtract the smaller arc, and take 1/2, and that will give you the measure of this angle here. So let's say I'm going to put some variables on here. We'll call this A, B, C, D, and E. And I know the measure of arc BD is equal to 30 degrees, and the measure of arc AE is equal to, we'll say, 80 degrees. To find the measure of angle C here, we're going to do 1/2 the difference of my two intercepted arcs. So I would do 80 minus 30 will be 1/2 of 50 degrees, or angle C is equal to 25 degrees. All right, next we have two theorems with secants and tangents. And our first one says if an angle is formed by a secant and a tangent that intersect on the exterior of a circle, then the measure of the angle, again, is going to be 1/2 the difference of its measures of intercepted arcs. So that would be a circle that would look something like this. So you would have a secant, and then and let me fix that for you. Let me make that a little bit better. And then a tangent. So the secant goes through at 2 points. The tangent will meet the circle at 1 point. But again, to find the measure of this angle here, you do the same thing. You do 1/2 the difference of your intercepted arcs. So in this case, it would be this arc and this arc. Subtract them and take 1/2 of that to find the measure. Our next theorem is going to be if a tangent segment and a secant segment are drawn to a circle from an external point, then the square of the length of the tangent equals the product of the length of the secant with the length of its external segment. So here what we're going to do is I'm going to draw a circle. All right, and then again we're going to have a secant and a tangent. Okay. So let's label these. We'll do T, W, V, and X. So it says if a tangent segment and a secant segment are drawn to a circle from an external point, then the square of the length of the tangent, so my tangent is Vx, so if we square Vx, it is equal to the product, so the multiplication, of the length of the secant, so the secant would be Vt times the length of its external segment, or VW. So it is equal to the tangent squared is equal to the product of the length, the entire length of the secant, so VT, times the external segment. So if I do, let's see here, I'm going to say that our tangent segment here is going to be 8. The external segment VW is going to be what we need to find. We're going to make that X. And we're going to say the length of the entire secant is 12. If I want to find X, we're going to do 8 squared is equal to X times, or 12 times X, or 12X. So that means I end up with, I'm going to move up here where I have more space, 64, if I square 8, is equal to 12X. And then we'll divide by 12. Now, it's not going to simplify nicely, but we'll say X is equal to, I can simplify the fraction, and I know it's going to be 5 1/3 if I make it a mixed number. So X would be 5 1/3. All right, here, just of some vocabulary here, we have a triangle and a circle listed here, and the sides of the triangle are tangent to the circle. So that means that the circle is inscribed in the triangle, and the triangle is circumscribed about the circle.